Hello, Algebra 2. Tonight's topic is day 5 in Unit 6, so 6.5, and we'll be talking about parent functions. We're going to be reviewing the 3 of the ones that we've learned so far this year and learning 2 new ones. Our essential question, and remember you put that under your name on the notes here, is how can I use my knowledge of the parent functions to graph functions? So let's go ahead and get started. So our first one is realizing what parent functions that we know. And the 3 that I listed, and we actually know a 4th one already, but the 3 that we're going to review today is first our y equals x is our line. So that's our linear function. That's one that we know. Our y equals absolute value of x is our absolute value function. And our third one is the quadratic, or y equals x squared. And our 4th one that we learned last unit, I'm just going to write the word, is called the cubic. And we also learned the quartic. And remember the cubic goes something like this. So our cubic is y equals x cubed. We aren't going to do that one at depth, but I did want you to remember that one. So the 3 that we're going to do in depth is linear, absolute value, and quadratic. Okay, so remember, if you forget your parent functions, you can always create a table to help you remember. So for the linear and our y equals x graph, down below in your notes you will also see the equation of our linear absolute value using AH and K, and we'll be talking about that next. But first let's think about the linear graph. When you create a table, a lot of times we start with the origin. We don't have to, but we usually plug in x values to find the y. And a lot of times we start with plugging in 0 and then use logic from there as you plug in. So for our y equals x, our linear function, if I plug in 0, y is 0. If I plug in 1, y is going to be 1. And then if I plug in negative 1, y again is negative 1. So every value of x for this equation will have the same y. So we can see the pattern here. And we can go ahead and plot our parent function for the linear. Okay. Okay, so for the linear, I went ahead and paused and brought up the line and went ahead and drew a line through those points that we were plotting. Now let's talk about our absolute value, and let's change colors here. Let's do the absolute value in green. So remember our absolute value, this signals absolute value, our bars here, and remember everything that comes out of our absolute value is positive, because remember our definition of absolute value is a distance from 0 when we're solving equations. So everything that comes out, every x that I plug in here will come out to a positive number. And let's go ahead and just plug in some values. And let's start with 0. So I plug in 0 into here. Our y will be 0. Okay, if I plug in 1 for x, our y is going to be 1. But if I plug in negative 1 for x, that's going to, for the absolute value, it's going to make that positive, and that will make that 1. So you can see our shape, and hopefully you're remembering this from Unit 1 and on our different reviews that we've had. But you'll see all of our tables, the value of y becomes the positive of the x. So if I plug in a positive number, it's going to be the same. And if I plug in the negative 2, then my y is going to be positive 2. Okay, so let's go ahead and graph that parent function. And this again is our v when we're using our hands, this will notice our V. So I'm going to pause again and bring up and draw in those points. Okay, so for absolute value, again, we have our V, and both arrows are going up, and there's ends right here at 0. For our quadratic, let's go ahead and do that in red here. And again, we're plugging in y equals x squared. We plug in for x, and we find our y. So go ahead and pause and try that. Okay, so hopefully you plugged in, you used 0 as a good starting point, and then 1 and 2, and then if you plug in -1, you would get +1, and then here I showed my plug-in of -2. So remember, when you're plugging in any number, you use parentheses, and then for this problem, all we're going to do is take that plug-in and square it. So for -2, so it's -2 times -2, and that's a +4. So if you plot your points, there's 0, 0, and there's 1, 1, and then plot 2, 4, and then -1, 1, and -2, 4. Okay? Now go ahead and draw your quadratic. Remember, it should look like a U. It should be U shape. Okay, hopefully your pause the video and your graph looks like mine. Please, if you have questions about this, please write them off to the side here so that we can answer those in class about the old functions. So the next topic now is reviewing how these equations, these three equations with our a, h, and k, because these same a, h, and k that we did back with the absolute value, remember you were in a group, you were either a group of a or a group in h and a group in k. And these are going to be the same with our new functions. So remember, the equation of a line is y equals mx plus b, and in this case, the mx plus b is our a, and our b is our k. So they're going to do the same that we're used to. The a is changing our slope, and you're pretty familiar with that from Algebra 1, and you reinforce in geometry. And then B is, remember, moves the line up and down, just like the K does. For absolute value, we have all three, A, H, and K, and then quadratic. Again, our A is always in the outside and the front being multiplied, and then our H is inside with all our functions, and then the K is on the outside. Pause the video and see if you remember what A, H, and K. Feel free to look at your old notes and fill that in. Okay, so remember, A is changing the shape of our graph. So if it's negative, it will reflect it horizontally. And a lot of times we were talking about it flipping the graph. But if it's negative, it reflects horizontally. And then remember, if it's a number of like A, like 1/2 or 1/3, but not every fraction, because it has to be a number between 0 and 1, or -1 and 0. So -1/2 or +1/2 are good examples. Then remember, it compresses the graph. It pushes it down toward the x-axis. And if A is greater than 1, or it's less than -1, then it stretches the graph. So like a rubber band, think about it, it will make it narrow as you're pulling a rubber band. If you're holding a rubber band on the ground and then pulling it up, it's stretching the graph. That's probably the most complicated one. H is also a little bit tricky. It moves the graph left and right, and it's going to move it the opposite way you think, because look at the way the equation is written. See how H is subtracting here? And it will for all of our functions here. So if an H is a positive number, it's going to keep x minus H is actually, so it's going to say, let's give an example of y equals x minus 5 squared. In this case, it's actually moving 5 to the right in the positive. If it was the opposite, x plus 5 squared, it's actually moving it to the left because of the way the equation is. It's going to move the opposite of what you think. And our vertex again is h and k, so that helps you remember. You can always plot the vertex, your endpoint, as we were talking about the new graphs, just by plotting h and k. That will give you your vertex for any of our functions or our endpoint. When our k, remember, moves the graph up and down in the same direction as you think. So if it's a positive k, it's going to move it up. And if it's a negative k, then it's going to move it down. Okay, let's look at our new functions. Our first one is our square root function. So we've been working with radicals, solving equations, and simplifying. And now we're going to get a chance to look at what the graph is. So I want you to go ahead and try to first just plot the parent graph. Plug in values for x and for your y. See what you get. So go ahead and try that. And bring it back. Okay, so hopefully you tried some values and hopefully you picked perfect squares, so to make graphing easy. If you tried any negative, remember you're going to get an imaginary. So you can't, there won't be, our endpoint won't be able to, if we can't result in a negative number in graph, that's an imaginary. So those we can't get a y if any value in here is negative. So, but for our parent graph, we would choose 0, 1, 4, and 9, and then take the square root to get our y value. So hopefully you pick those and you got dots similar to mine. So 0, 0, then 1, 1, and then 4, 2, and then 9, 3 is a good one just to realize based on where your graph starts. You'll want to know that value too. So let's just graph what our function looks like. So it will not go past this endpoint because we can't put any negative values in. And again, our h and k are going to work the same. As you can see, our a, same thing we just covered, it's in front, but in front of our square root. Our h here is inside our radical, our square root radical, and then our k is on the outside. And we're going to be using those in a few problems here in a few minutes. Before we do that, let's take a look at the parent graph of the cube root function. So the cube root function is just like what we've been working with in class. We have a cube root, and our x is under the cube root, and it's set equal to y. That's our parent graph of our cube root. So go ahead and try, let's go ahead and try some points on your own. Plug in x values, think of perfect cubes that you're using so that you can get a nice graph. It's easy to plot on your grid. Okay, so in this case we can take a negative cube root of our for our value. So think of all your perfect cubes. Negative 8, if I plug that in for x, would be negative 2 would be the y value. Another perfect cube would be negative 1, and that would be negative 1, and then 0 as x would result in 0 for y, and then 1 for x would result in 1 for y, and then the cube root of 8 is 2. So here's my x's and y's, and then I just plotted them over here. Our 0, 0, 1, 1, and then went 8, 2, and then negative 1, negative 1, and negative 8, negative 2. So this graph looks like more like a, if you're using your hands, more like a, if you've heard that song, Walk Like an Egyptian, kind of looks like that kind of motion with your arms. Okay, let's try, again, the same with the A, H, and K. See where they all are again. Let's try a few to graph on your own using your parent functions. So use those new ones. This K, again, is up 3. It's on the outside. And this is in the inside, so it's left 1. Go ahead and try those two on your own and then bring it back and compare with me. Okay, so hopefully you noticed that this was a cube root, this first one, and it's up 3. So I showed my parent graph for the cube root in black and the function they want us to do in blue. And then for the second one is square root function, and it's in green, and the parent graph in black.